Good morning, everybody. Hope everybody's doing good today. Hopefully the video looks a little bit good. I feel like it looks a little red now. I was messing around with the lights. I put some LED light bulbs instead of fluorescents, but I think the colors look a little weird now, so bear with me on that. All right, so let's just go ahead and continue where we left off yesterday, actually. Well, actually, first let me tell you what we're going to cover. Good morning. Oh, by the way, Castores, you did the extra credit, but you didn't tell me who you are. Send me a message on Discord, because I have no idea who you are, so I don't know who to give the points to. So, yes. Anyways, so today we're going to continue talking about the switch statement, and then we're going to kind of go and talk about the for loop, the other major loop that we haven't talked about. Then we're going to talk about break and continue and how they affect loops. And actually, we're going to kind of jump back to talk about switch statements. Oh, yeah, thank you. I'll bring it closer. Yeah, I forgot about that. I always forget. But yeah, so after we talk about the for loop, we are going to be talking about break and continue. And then we're actually going to go back and talk more about switch statements and how that break keyword and switch statements actually works out. And then if we have time, we'll start talking about the file IO. If not, then we will dedicate tomorrow for that. And I think that's going to wrap up the contents of the first exam, which will be next week. So I have an announcement set to be sent out to everybody right after the class ends. So then basically confirming that we will indeed have the midterm next week. So we will not have a class on the day of the midterm because the midterm is going to be basically at the time of the class anyways. And I don't know if we will have a review yet. If we end up having one, it will have to be outside of the regular class time because we need the time for the class. So it could be right after the class, or it could be just a different time. I don't know. We will figure it out. But okay, anyways. Let's go ahead and then switch to the code. There we go. Okay, so actually give me 1 second because that's really bothering me. Let's see. Let's just bring this down a little bit. Okay, there we go. I think that looks more natural now. I don't look super red. So, okay. Yeah, all right. So is the midterm multiple choice or a coding assignment? It's going to be a combination of, I don't think there's actually any multiple choice in it. It's a combination of coding and like short answer questions. So we'll talk more about that as the time comes. But yeah, pretty much that. You will be coding on the lockdown browser, which means you don't have the compiler with you. You have to kind of code without it. So you're going to be coding in just pure text. So that is a little bit harder because you don't have the IDE to help you not miss things like semicolons and things like that. Because we are testing that you know this, not that the IDE knows it. And then the short answer questions will be explanations of things like how does an if statement work, that kind of thing. So this weekend I'll make the test. So then of course I can actually give you more details, but that's kind of what I'm going to go for. Okay, so again, we are going to talk about the switch statement right now from where we left off last time, but we're not going to finish talking about it because we got to talk about break and continue first. And actually, we might be able to talk about break. Yeah, okay, I'll flip it around a little bit. Let's talk about break and continue first, all right? In the context of the while loop that we talked about last time. I think this will work out better because then we can completely cover switch statements in one go. So, okay. So if you remember last time, we had a little while loop that did a lot of things. In this case, though, we're just going to have a loop that runs for infinity. We can do that by putting 1 there or just putting the word true. And then we're going to keep a little counter outside. We're going to initialize it at 0. And then we're going to go ahead. And actually, I'm going to combine because it's kind of cool. I'm going to go ahead and combine my counter with the increase and then print it out at the same time. So here's a little poll for you guys. Yeah. What is the first number that will be printed out? Okay. And I'm gonna put a bunch of numbers here. So like that. And don't yell out in chat. Don't yell out in chat. Go ahead and put it on the poll, on Twitch poll. View results. Okay. So the question is, in this program, assuming it says counter, not count, so that it actually compiles, what is going to be the first number that's going to get printed out? Is it going to be -1? Is it going to be 0? Is it going to be 1? Is it going to be 2? Or I suppose it could be something else, but I don't think it is. Okay, I don't know if you guys can see the results as it's coming in, but I can. And I'm seeing a very diverse vote, basically. Let me go ahead and actually, in the meantime, switch to the folder where I have that, which is now 6. I don't know why I'm numbering these. Like I said, at some point, maybe before the midterm, I could like upload all of these in a zip file on campus, and you guys can play with them. If you guys remind me. Okay, the poll finished. So the winner is 1. Okay, so the winner is 1. And what is the actual answer? Let me see. It says counter plus plus. I think you guys are gonna go in for a little surprise. Okay, I guess let me go ahead and rerun this and end it really fast, so I can try to catch it. Nope, I can't. Okay, so the way I'm gonna actually get it so I can stop it is I'm gonna be using, actually, even though I haven't talked about it yet, I'm gonna be using the break statements. Surprise, surprise. But it turns out that the answer is 0. And only 1 person voted 0, and 5 people voted 1. And then 1 person voted -1, and nobody voted 2. So yeah, I'm not surprised that the majority of you guys got it wrong, because it's a very common issue that people have. Remember, it's not the focus of today's discussion, but the reason I bring it up is because it's something that always gets people, and I'd rather get you now than in the test. And that is the idea of pre and post increment. So this is post increment, and what this means, yeah, this break actually just jumps you out of the loop, and I'll talk about that in a second. But first, I want to tell you guys why it's 0 and not 1, as you guys thought. And the biggest thing is because, remember, post increment, and that's when you have the plus plus after, in comparison to pre increment, which is the plus plus before. With post increment, what happens is, if you're assigning it to something, so if I have something like A equals B plus plus, like that, what is happening is I'm getting the old value of B into A, and then I'm increasing the value of B. So if B has like 1 in it, then after this, A is gonna have 1, and B is actually gonna have 2, okay? And so the same thing kind of happens here. When you're calling cout, it's gonna print out, you can think of cout kind of like an equal sign, so the getter, and it's kind of giving it the value from counter. And because it's post increment, it's giving it the current value of counter, which is 0, and then it's increasing it. So if I was to call out cout counter here, again, without the plus plus, then you would see that counter actually does have a 1 in it. Cout. Let me spell that. See, it does have a 1 in it, but the first time you call it, it's getting a 0 because of the post increment. If I wanted to have it a 1, I would have to do pre-increment, and now in this case, I'm gonna get 1, 1 for both, as you can see, because there it increases it first, and then gets the value, like cout janks it out and actually prints out that value, okay? So be careful about that. Make sure you don't get them mixed up in the test next week, or in general when you're coding, because it's a headache if you don't know what's happening. So anyways, notice that I had to use this keyword break because this loop was looping forever. Actually, this is a good usage of that. So let me actually talk about what this keyword is. And this is a reserved keyword in C++. And what it does is, as you're running inside of a loop, the moment that you see a break statement, it tells the program to automatically, in that moment, instantly get out of the loop, like terminate the loop. So normally your loop is going like running, gets here, goes back to the top, checks this. If it's true, then it keeps going and going and going, right? Break is kind of like a emergency exit button, like this big red button you push. And that's basically what's happening. When it sees the command break, it halts the loop and just automatically gets out. So if I had a statement here that said in loop or something, just a print statement, this would never get printed out. If I, of course, comment this out, then I'm going to get an alternating sequence of increasing numbers and the word in loop, you know, nonstop until I manually terminate it. But if I go ahead and add this break command, all I'm going to get is the first number printed, and I'm never going to see the in loop there, because the moment it sees the break, it just ends the loop, okay? Process is not the right term, as somebody said, because when you think of process, you're thinking of a program. It's not ending the program, it's just ending the loop. So if there's code after here, so like there's a code that says loop is done, this will still print out, as would something before the loop. So if I have something here called before loop, it's always fun typing without looking at the keyboard sideways. So here we have before loop, then we get to 0, then the break happens, and then you get that. In fact, here, let me move this so you can see side by side. This happens, you're seeing the before the loop, then it goes in because the true evaluates the true, so you're going in the loop. And then you see cout counter plus, which goes ahead and gives it a 0 and increases counter, breaks you out of the loop, so this never runs, and then it continues from the loop is done, and then you get the end line. So yes, the right answer is, that is a very good way of saying it with the right keyword. What happens is it gets you out of that loop, and also basically gets you out of that scope, because that loop has its own scope, okay? So yes, it's going to just kick you out of the loop immediately. Yeah, that's pretty much what break will do. Now, here's the thing. We haven't really shown you an example, but I mean, why not now? You are, just like you can have nested if statements, you can have nested loops. So I could have another loop here that, you know, this time maybe not run for infinity, but let's go ahead and say, well, counter is less than 5. And then maybe here, let's return another variable. Let's call that an interior or inner counter, I suppose, equals 0. And then we're saying, well, inner counter is less than 5 as well. Or maybe here 2, 3, bigger number. Okay, so I can go ahead and in here, I can say I'm going to go ahead and increase inner counter plus, and maybe I'll do the same thing. Cout I for inner counter, and then the number. Maybe put a space there, and then end line. Okay. And let's go ahead and take out the break just so we can see it. So this is getting a little bit complicated, but it's okay. What you're going to do first, or what's going to actually happen here in the program is, it has a counter called int counter, and this logical expression is looking for when counter is less than 5. And if it is, it's going to go in. Of course, it's 0, so it should automatically go in. It's going to print out 0 as we saw. Then it's going to declare a variable inside the loop that says int counter equals 0. Now remember what I said last time. You got to be very careful about declaring variables inside of loops, especially because you should be initializing them, right? This means that every time this loop runs, the outer loop, this one, this is going to be a brand new variable with a brand new 0 in it, okay? So you got to be careful about that. But here it's okay, because we're actually declaring this variable so that we can use it inside of the inner loop. Now this inner loop is going to run from when inner counter is less than 3. And because it starts at 0, it should run when initially. And then when you get in here, it's going to be increasing it by 1. So this should actually run how many times? Let's think about it. At first it's 0, so 0 is less than 3. The next time it's 1, 1 is less than 3, so that's 2 times. The next time it's 2, 2 is less than 3, so it keeps going one more time. But then 3 is not less than 3, so it's only going to run 3 times. So I should get the I printed 3 times, at least the first time that you hit this loop. Then I'm going to get the in loop, and then I'm going to go back to the top. this outer counter started at 0, but it went to 1 here. However, 1 is less than 5. So then it's going to run again. So I'm going to get here, I'm here. In fact, I'm going to, so that you can see the difference, I'm going to go ahead and throw in here an O for outer. And so we're going to print that outer. And then again, we're going to declare another variable called inner counter, because the other one disappeared. When you went back to the top of the loop, it just vanished. You can think of that. And here's the thing. Now I'm going to go back into this loop. This loop is going to run again, and it's going to run 3 more times because it's going to go in until the inner counter gets back to 3. Then it's going to go to the bottom. Then we're going to go back to the top. And now here it's going to be a 2. 2 is still less than 5. So you're going to go in. You're going to print out 2, and counter will have a 3. Inner counter will be set to 0. And then yet again, I'm going to go into this inner loop, and it's going to print out 3 more times. So the question to you is, how many times do you think that the letter I is going to be printed in this program? And for this one here, you can just blur it out so I don't have to run another poll. How many times, the way that I have this program written, do you think the letter I is going to be printed before the program terminates? And I'll give you a hint. It's a positive number, and hopefully it's not infinity. So unless I made a mistake. But there's a very easy way of figuring out. So how many times the I will print out in the entire program? Not like the whole program. Like if I run it right now, how many I's am I going to see here? Okay, so I'm getting a couple of different answers. I'm getting, I don't know what 3 times, what do you mean by 3 times? I'm getting one W, I don't know what that means. Then I see 15. Yeah, okay. I like that one. Why did you think 15? Like, how did you come up with that? How did you guys, now I see 2 people with 15. How did you guys like come up with 15? Like, what was your reasoning behind that? That's the real question that I'm going to follow up you guys with. 5 times 3. Very good. Yeah, that's pretty much it. This outer loop is running 5 times. The inner loop is running 3 times. Because every time this outer loop runs, this inner one's going to run. It's basically a multiplication. Yeah, 3 times 5. That is very, very correct. And if we were to run it and count them, we should get 15 of them. As you can see, it's going in pairs of 3s. We got 1 of them, 2 of them, 3 of them, 4 of them, and 5 of them. If we want to count it, by the way, inner counter, it gets reset, but we can actually create another counter. We can just call it like int total counter, set it to 0, and then after the I here, let's just go ahead and increase it. Total counter plus plus. And then at the end of this, when it says loop is done, we can go ahead and just in there throw it in so it prints out. So total counter, kind of dubious variable names, but okay, 15. So yeah, that matches exactly what you guys said. And you're absolutely right. And that's the reason why I made a point of doing this little exercise is because it's an important thing that you guys come to your own realization instead of me telling you that when you have what's called nested loops, again, when loops are inside of other loops, and this is going with the scoping rules. This is the tip of the mountain, and then this is kind of like less in the mountain, and then this is less in the mountain, and then you got your global scope, which is like flat land. So those scoping rules still come into play. But the way you can calculate how many times code inside a loop is going to run is if you have loops inside of each other, you basically multiply things together. And I went ahead and looked over the homework, and I do make you do the power function in the homework, and that's that can be done in one loop. But if you were trying to do something more complicated, you could definitely do something like nested loops, and they're very, very useful for when you need to run something in relation to another. Like this needs to run 4 times for every one of these. What could be an example of that? Something where like ratios are different. Like let's say that you're making a simulation of a student in school, okay? And so you're trying to simulate that he takes 4 classes every semester, but he's going to be studying for a total of 10 semesters in the school before he graduates. So how many classes is he taking? Well, each semester is 4 classes, and basically you are taking it for 10 of them. So basically you could think of the classes as the inner loop and the semester as the outer loop, which is running 10 times. And then there you have that multiplication. You're going to get 10 times 4, which is going to be 40 classes potentially, which is times 3 would be 120 credits, which I think is around the amount of credits you need to graduate. I don't know. But yeah, so that's very, very important. Of course, it's not always this clear as with a counter. Sometimes it's a little bit trickier to figure out how many times something runs when it's not just numerical based. If you look at the example last time when we were reading in from a file, there's no way for us to know ahead of time because we don't know how many words are in the file. That was the whole purpose of the program, was to count how many words, right? But you could have a nested loop there if you wanted to count the number of letters in fact, maybe we can do that. Yeah, we could probably go ahead and do that. So let me go ahead and reopen the while assignment. I think it's this one. Oh no, Wiki CPP. Yeah, I think it's this one. It's sad. We did this exactly 24 hours ago. Less than 24 hours ago, I think, and I don't remember it. Oh, okay, yeah. So that's the file itself. So I guess it must be loops. But hey, 23 hours is a long time. That does not look like. No. Yeah, this one. We did Linux redirection, I think. Okay, let's give it a try. So CD, I think this is in 5. G++ loops. Ready, set, go. Okay, so then let's give it as an input file. By the way, if I did this like this, I'm gonna overwrite my wiki.cpp file with nothing basically. So that'd be pretty sad. So I want to make sure you don't get that backwards. Okay. Cool. Yeah. So okay. So in this, we are able to count the number of words, right? But let's go ahead and count the number of letters. And if you remember with the WC command, and if you don't, you can do WC help. Remember that up here it said that when you run WC, it prints the new line, the word, and the byte count. So when you do WC wiki CPP, it means these number of lines, these number of words, these number of characters. So now we're going to try to get this number out. This is our goal right now. And right now we're counting letters, and we're counting words, and each word is in temp. So now what we want to do is we want to count how many letters or characters are in temp. How can we do that? Well, we don't want to do it actually here because that's just for da. We want to do it out here. What we can do is we can put in the loop. We can say while temp. So basically the idea is we're going to loop through each letter in the word temp to find out how big it is. Now, I'm going to kind of, I'm going to have to cheat a little bit because you guys don't know arrays, but, you know, the way that I could do this is I could manually go in letter by letter and count them. So, although there's actually another way we could do this. We could just go temp.size, and that might actually do it for us. So let me try that first, actually. So let's go ahead and add int letter count. Actually, even though we're going to do temp.size, let's count the number of E's in the text. That's a better one, because that one we can't do with temp.size. That's actually a harder thing to do. But for now, I am actually curious to see if we get the right value by just doing this. So let me just try this really fast and let's see what happens. Let me see. There were cout. There were, and then letter count, words in the file, or sorry, not words, characters technically. Okay, so let me go ahead and just run this because I'm curious to see if we get 308.55. Okay, I forgot my little plus here. So otherwise we're basically just counting the number of words in the last word that was read, the number of letters in the last word. Okay, so we got a completely different number. The other one was supposed to be that. So why the discrepancy? The discrepancy is probably due to characters that are being ignored by CN, and those characters are going to be your blanks, your line feeds, and basically everything that's just punctuation Actually, punctuation would not be ignored by the other one. Just basically blanks, white space, as they're called. White space, because it's anything that's that's like a space, a blank, a new line. Those are those characters, and that's why there's a discrepancy there. But these are the ones that we're actually counting, I would say, are like the real letters that we're actually counting. So just because that's different, that's not necessarily mean that we're wrong. Okay, so now what I'm going to do is I'm going to try to count. Instead of just doing the letter count, what I'm going to do is I'm going to try to count the number of letter E in the entire text, okay? Because I want to show you a nested loop. And so in here, I'm going to create a local variable called, actually, I don't have to. I can just keep using the letter count. I'm going to put my inner loop, and I'm going to say while, oh no, I do need a little index. So I'm going to create a little variable called index, set it to 0. And I'm going to say while index is less than temp size. And what temp size does is that returns to me the size of the string, which is the size of the word. We talked about that, we were talking about the libraries. So yeah, we're going to go ahead and run with that function, okay? And so in here now, we need to count the number. What this is going to do is this is basically going to run the amount of times that we have letters, okay? As long as every time that we run, we remember to increase the counter by 1, like that. Okay? And so now what we need to do is we need to check if a specific letter is an E. So we're going to say if something equal to E, then we want to just basically, let me put my curly brackets in there. We can just then say letter count plus plus, which will increase it. Now, there is something that I left blank there. How do we actually go through each index? This you don't know yet, and this we won't talk about until after the test. So for now, just bear with me. What we need to do is that little magic that I was talking about with the arrays the other day, which is just that. The name of the string, and then the little square brackets, which are how you select an index. Remember the parking lot example? That's where these are coming from. And then we're basically going through each of those. So that we haven't talked about. But at least you can see the part where there's nested loops. So there's a real usage of these, actually. And we got a 0. If temp index equal to E. Why did we get a 0 there? Well, temp index, less than, not greater than there. So this is semantic error. Instead, I was basically saying, while the index is bigger than temp size, but the index starts at 0, and unless the word was size 0, which it couldn't be, because otherwise it wouldn't have been read into temp, then this never was being executed. Hence why we get getting a 0 there. So we got 2,800 characters, and those are E's. That's a lot, but that's expected, because remember, T, L, and E are like the most popular characters. If we go with something like a Z, this should go down to like, hey, I'm going to take a quick guess. I'm going to say about 100 of them. 45, not bad, not bad. So there you go. So it works. At least it seems to be working. I don't actually want to count the number of letters. Maybe word count has a function for being able to do that. Like not a function, but an argument for counting specific letters. If not, there's something called grep that would actually help you out to do that kind of thing, or RE. But yeah, so here's just an example of, even though we haven't done this yet, here is an example of using a nested while loop. Another usage that we'll see later on the course is going to be when we talk about sorting and searching. And in general, if you remember, like I think day 1 or day 2 when I was talking about approaching problems, and I said divide and conquer, and also another way of splitting a problem into smaller subsets, in a way that splitting it into these loops is doing that. You have to, if you're thinking about this problem that we just did right now, we wanted to count the number of letters of a specific letter in the text. Okay, we don't just flat out start from scratch and say, okay, yeah, we're gonna do this and this and this. First, we split it into smaller problems and say, okay, first we gotta actually read the file in. How are we gonna do that? We're gonna use linear redirection. Okay, next. What can we do? Well, we can use cin to read in individual words. There are ways that we can read in individual characters. We don't know how to do that yet, but we for sure know how to read in words. So okay, we can read in words, and that can be a loop. And then once we write a word down, now the problem is much smaller. We're no longer trying to count the number of Z's in an entire text file. We're just trying to count the number of Z's in a single word. That's a much easier program to tackle. And then, of course, we can go and look at each letter individually in that word and compare it to a Z. That, of course, we don't actually know how to do yet because we don't know how to deal with arrays. But, you know, I got to show you. You basically use a little index to look through each of them. But as you can see, it still applies to the idea of dividing and conquer and splitting the problem into smaller steps. So that's one of the things that you should definitely start to get practice with. But anyways, that's just an example of a nested while loop, and I thought it was kind of a good thing to show you that. Because text processing is a cool thing in general. Okay, so now we're back to ours. And so let's go ahead and throw in our break keyword again. So break again is our emergency exit. And we're going to go ahead and put it there. And now my question to you is, how many times in this program is the letter O going to print out? And how many times is how many times is the letter I going to print out? Yeah, how many times is the letter I going to print out in this program? So go ahead and blur out in chat while I switch over again to this program. Where am I? CD. So yeah, go ahead and put it in chat while I switch over. There we go. Okay. And now I'm ready to run it. So 5 times. Yeah, I think that's correct actually, because what's going to happen is and of course, you know, it's okay if you guys don't know the answer because I haven't really given you that many. I mean, you know that the break command gets you out of a loop. But what I haven't really told you yet is that it only gets you out of the nearest loop that you're in. So the closest scope. So the break, even though it's like, I suppose you can think of like an emergency exit, it's only an emergency exit for the nearest scope. So it's not going to get you out of both loops. And because of that, when this first runs, you're going to get an O, and then you're going to get an I, and then the break is going to get you out of just this loop, but you're still in the other loop. So you're going to print out in loop, and then you're going to go back to the top, and it's going to go run again, and you're going to hit this I. Then you're going to see the break and get out. So really, as somebody said, it is going to indeed print out 5 times. And we have a little counter that confirms that, or we can see the I's and count them by hand. So the answer is 5 times. And that's again because the break command only gets you out of the nearest scope per se. There's actually no way in C++ unless you terminate the program, which you can. By the way, this is not something that's really covered, but it's kind of useful. Using the exit command, and I think you gotta put a 0 in there, if I remember correctly. Let me try that. Not exit. Well, I guess maybe not without it. Exit was not declaring the scope. Maybe quit? Is that the one? I'm thinking Python. There is one way that you can just flat out terminate the program at that specific spot, but I can't remember it right now. I mean, in this specific case, I could just put return because we're in a function, but that's not really the way you want to do that. Program C++. I could have started as exit. Yeah, exit. Okay. It's because it's in the header file. The header file for using exit is stdlib.h. Okay. So now let's go ahead and try that again. Okay, so okay, great. And that means you just gotta give it a number here. And I think now we should be actually okay. Yeah. And then it just terminates. Okay, perfect. I'll go ahead and post a link on chat. So there we go. That's again, if you don't remember something but you know it exists, you can Google it and then get your details out of that. So know that there is a command that you can call to just completely terminate your program right there and then. It's not a good way of doing it. It's really only meant for like when you're debugging stuff, for like I guess real emergencies per se. But there it is. It's quite convenient and useful. All you gotta do is type the word exit. It's like a little function, and then the number here. We'll talk more about that when we talk about functions. But this 0 is actually the same thing as this 0, and it's a little sign for the operating system. I don't think it'll actually tell us anything if we put one here. But sometimes it'll actually say program terminated with exit code, and then that code number would actually be the number you pass it here. I don't remember how to do that in C++, but yeah, I'm sure you've seen that in some places. If not, don't worry about it. But anyways, that's not the point of the discussion, but it's still quite useful. As you can see, there's so many things that it's just impossible to cover all of them, you know. So yeah. But anyways, break is not as harsh as exit. It's just meant to get you out of the nearest loop. If you needed to get out of this loop as well, then you have to put another break. But suppose that you were trying to be ingenious and break out of both loops at once. Like, could you do that? Could you make one break do both? The answer is, well, there is a way you can kind of mimic that behavior. And for that, you can create a Boolean. Let's just call it emergency or OMG. How about that? OMG. Bool OMG set to false, okay? And if there's ever a situation, so in this case, we're gonna say our situation for the emergency is inner counter is equal to 1 or greater than 1 or greater than 0. Nah, greater than 1, because then it'll actually run one time and then the next time it'll actually freak out. So perfect. In that case, we can go ahead and set OMG to true, because that's going to be our emergency situation is when the inner counter is equal to 1, okay? Why do we need a break? Why do we write a loop if we needed a break? Because I'm trying to just show you how break works. There's no real reason why we put it here. In fact, I was going to get to the spiel later on. You don't want to use breaks in your code unless you're trying to debug something, because it's bad practice. There's usually better ways of doing it. But yes. I'm just trying to show you examples of break. So anyways, now I'm going to show you an example of how to use break to break everything out. So like, let's say that your error that you're trying to just kind of exit out of the entire program or entire loops is that inner counter becomes greater than 1 for some reason. Again, there's no logical reasoning for that. So I'm going to go ahead and set OMG to true. And now I can wrap this break in an if statement that says if OMG, so if OMG is true, break. Now in this case, I could just basically go ahead and put that up here and that'd be okay. But the cool thing is now I can put this OMG on the outer loop like this. And let me put some curly brackets. You don't have to, but it could practice. And so now this will actually break out of both loops whenever this OMG gets set to true. Because once it's set to true, it doesn't get set to false again. And so it will completely break out of everything. So here's sort of a hackish way of being able to break out of multiple chains of loops if you ever have to. Yet again, you don't want to use exit because that just completely terminates the program. Maybe you still want to work with something after the loop. So maybe you want to have some code here like loop is done. But, you know, it's a useful feature to have. So as you can see here, let's go ahead and kind of look at the code and see what happened. We went ahead and ran the code. It says before loop, we get the Z out 0, 0, but counter should have 1 in it. Then we get the inner counter. Then we say, well, inner counter is less than 3. So we get an I. The inner counter becomes 1. And then from there, the total counter is just doing whatever. And then the inner counter at that point is 1. But this is greater than 1, so this is false. So it goes back to the top of the loop. 1 is less than 3, so it goes back in. Prints out I again. Now inner counter is equal to 2. Now this time, because inner counter is equal to 2, and you can see here that it printed out the 1, because again, the plus plus means that it prints out the old value. Then here, this is going to enter into this. OMG is going to set to true, and then you're going to call break, which will get you out of this loop. So it means you won't go a third time here as you would have otherwise. And then, of course, the next thing you're going to see after this loop is another if statement. OMG is set to true now because it was set here to true. And so, again, you're going to break out of this at that moment immediately. And that's why later on you get the loop is done. So this is an example of how to break out of multiple loops using break. So that's why the people who created C++ were like, we don't need to make break out of everything. That would actually be horrifying. Because there are other ways that you can still mimic that behavior using a Boolean that you just set to true, and then you just check that Boolean before you break out of all your loops. And you could do this in a chain of 10 loops instead of each other, like loopception or something. Okay? So that's basically how break works. On the other hand, there is another command that you should know, and that one is called continue. And it's kind of like the complement to the break command because it's similar in behavior. It's a reserved word, and what continue does is, again, when a loop is running and it sees this continue, it stops that iteration. But whereas break will kick you out of the loop, all that continue does is it just goes back to the top of the loop and is going to check the condition again. So basically, it's if there's any code here that's still inside the loop that would have otherwise ran, it's not going to run. The moment it sees continue, it's going to stop that iteration of the loop and is going to go back to the top of it and then check the condition again. So it's kind of like a shortcut to back to the top. And yet again, there are kind of weird cases where you would do that, but typically you don't want to. So in this case, the way that I have the code now, what's going to end up happening is, if I run this, I'm going to go back to the way that I had the code before I mess with it and add break to anything. I'm still going to get all the 15 now. Because before any of this weird code runs that I was messing with the OMG variable and calling break, and then this will never ever run because every time it's going to go back to the top. And of course, because of that, OMG will never be set to false, to true, which means this will never run. If I go ahead and move continue up here, or just put another continue there. Now in this case, I'm never going to see an I printed. All I'm going to see is O's printed. Actually, oh yeah, this is cool. In addition to seeing only O's printed, now I have an infinite loop. As you can see here, the program didn't terminate, and it's just blinking there. And now it's frozen. Let me close it before bad things happen to the computer. Why? Because the continue, like I said, brings you to the top of the loop. But unlike this continue, the continue goes back to the top of the loop before this ever increases. And because this is never increasing, inner counter stays at 0. And so it's just constantly checking whether inner counter is less than 3, but you're never increasing it. So it's stuck at 0. So it's just kind of going back and forth between lines 13 and 14, just like blah, forever. So, yeah. Okay. So, yeah, that's pretty much how continue works. As you can see, it's kind of like very similar to break in the sense that it kind of stops that iteration, but whereas break takes you out, continue just brings you back to the top. When would you use that? It's tricky sometimes when they ask you that question, even though you do find yourself using it sometimes. If you have a lot of code that you're running and processing, let's say that you're processing some text, and you are trying to count the number of E's and whatnot like we were doing. But suppose that whenever you see a word that starts with a specific letter, you want to ignore it. In that case, you don't want to use break because you don't just want to kill all the loops, but you may want to hit continue so you can keep going to the next word. And so that may be a usage of continue. Now here's the thing. I've shown you how break and continue works because I want you to understand that if you're looking at code that has break and continue, or in the test if I ask you to, right? But more importantly, if you're working with code and you see break and continue in a language, you know how it works. But by the same token, I highly discourage you from using break and continue unless it's a very clear choice and it's like you're really, really good at programming, which at this point, if you're new in programming, then you don't know any better per se, right? Eventually you are going to become amazing and then you can make that judgment call. But for now, I'm telling you that break and continue are poor practices in programming. Why? When somebody looks at your code, like let's say I'm just looking at this code for the first time. In addition to, I already talked to you about why the tab is good, because the tabbing very quickly allows me to identify that this code is inside the while loop, and then that this whole code is inside that while loop. And then, for example, this line of code, because it's tabbed here, is not inside the loop, whereas this one is. So the ability to have a tabbed code like that is very useful for being able to see what code is inside of a loop or inside of an if statement. In addition to that, if I see this code here, again, this little loop here is what, like 10 lines of code? But let's say there's 200 lines of code here. I may miss, and there's a continue like in the middle of that. I may miss that as I'm scrolling down through code. And so if I see code inside of what I expect to be inside the while loop, I expect this code to run every time the loop runs. Just because, like, it's inside of the loop. right? Continue kind of disrupts that ability to look at code, because that continue, obviously, you don't just want to flat out call it. It's going to be inside of some sort of if statement. But in that situation, some cases, some code may not run. Similarly with break, right? If I'm just looking at a bunch of code, I just assume that if there's code down here, like if there's a cout high here, I expect that high to be printed because it's inside of the while loop. Now, if I don't catch this break amongst thousands of lines of code, then I will have no idea that this high may not print sometimes when that break happens or a continue happens. Either of those would not make this break print, either of this being called. That makes the code harder to read and harder to follow and more prone to errors and harder to debug those errors. And so this creates what people typically refer to as spaghetti code. And spaghetti code is really bad. It's actually probably an insult if somebody tells you that your code is spaghetti code. So yeah, that means your code is very hard to follow, because instead of kind of being easy to read from top to bottom, your code is jumping back and forth like this. And when there is that jumping back and forth, it's very hard to track the code down and to understand what's happening. And again, coding in the real world, not here because you can't help each other, cheating, but in the real world, it's about collaboration. And collaboration kind of means that multiple people are working on the same code. And if multiple people are working on the same code, they all have to understand what's happening. And you have a responsibility to make your code easy to read for others. Just like others have that for you, that courtesy. And so break and continue kind of make that much harder to understand. So most of the time, if your code has a break and continue, it can be rewritten with the same meaning, but it can be rewritten in a way that you don't need to use it. So, for example, let's go ahead, in this case, let's just get rid of the continue for now, but let's go ahead and rewrite this code in a way that the break still works here, but, we don't actually use the keyword break. What can we do? Well, this part of the logical expression can be moved inside of the while loop to basically check that and not run the code. So in this case, if inner counter is greater than 1 is supposed to stop the loop from running, then I can just go ahead and say and inner counter is greater than 1. Okay? And by doing that, then this doesn't have to run. This never needs to be checked. At least I'm solving part of the problem there. As for the outer loop, how do I actually get out of that easily? Well, I can go ahead and leave the Boolean there by setting this to false. Still making the loop break out by having it here. So I'll still have the thing here that says and inner counter greater than 1. So still leaving that there. But when the code runs and it sees this, oh my god, OMG assigned to true, then it's not going to break there. It'll actually break when it gets back to the top. And then it sees that. And then instead of having the OMG here, then I can go ahead and add it to here. And OMG. And now I don't need this piece of code either. I need to break that. But then you get the high. What if you want that high to print out? It would have still printed out here, because whereas here it would have immediately broken out, now it's going to go there. So then, how do you stop that? Well, then you have to reconsider how your code is working and why it's printing there. And if you really, really didn't want it to print there, then you can go ahead and say something like else cout high. And that means that while otherwise when this OMG gets set to true and it would have broken, here OMG gets set to true and then the else doesn't get executed. But if this doesn't run, then the high gets executed. So bam, now we fixed the issue with the high. Finally, we got the same thing with the loop thing here. In this case, we would have had OMG here and then they would have called break, but instead we want basically the loop not print out in that case, because otherwise, so basically here, when we get out of this loop, OMG is set to true. So normally here we would have called break at that point, and then loop wouldn't have printed. But now it's going to print one last time, which is not good. Okay, no problem. Then what we can do is we can say if OMG is not set to true, then go ahead and print out this. Because if it is set to true, then you basically don't want to print it out. So there are always ways that you can reorganize your code to not use a continue and a break statement. They are sometimes harder to think about, and that's why a lot of new programmers use break and continue, because in their heads they're like, this is when I want the loop to stop, so I'm just going to call a break right there. Yes, that's the lazy way of doing things. You're not really learning how to think logically and think in Boolean algebra. That's one of the things that you just have to practice, and then eventually you will learn. But avoid using break and continue, because there's always a way that you can do the same thing without it. And yes, the code may look a little longer, may look more complicated, but that's okay, because that's going to make it way easier for other people to look at your code and understand it. And even for yourself to look at the code later on. So that's the spiel about why you should not use break and continue. By the same token, you don't ever use a go-to statement. We don't even talk about those in any of the classes. Maybe in 202 we'll mention it if you take 202 with me or with somebody else. But again, that is the worst form of spaghetti code. So you can look that up on your own, but don't ever use it, at least in environment where you care about your reputation, I suppose, as a programmer. So, yep. There was one thing I wanted more to say about that, but I can't think of it now. Nope. I guess that's it. So now let's go back and talk about the switch statement. So the switch statement is going to be the one case, I suppose, where break is okay to use, because it's kind of part of a switch statement. So if you remember last time when I was talking about, I remember what I wanted to say now. My bad. A little bit about Boolean logic that I think I saw on Discord, and it kind of bothered me. Suppose that I'm trying to have, I suppose that I have a variable called, let me think of what I'm trying to say here. Yeah, a character variable. We'll call that character X, okay? And X contains something in it. Let's just say it contains a Y. All right? And so now you're trying to compare in an if statement whether X contains a Y or a N, okay? So if X contains a Y or an X, then say yay. Otherwise, don't say anything. Okay? And you can see here that it contains a Y, but I'm saying, maybe this is read in by user input. So the wrong way to do this is to think of is to kind of write it in the same way, or code it in the same way that you're saying it. You can say if X is equal to Y, or you can use the or if you don't want to use the two vertical lines, or X. Okay? And then maybe you even go ahead and put in some parentheses here, because you want to compare them to both. Either way, this is wrong. Because here's the thing. In English, yeah, if X is equal to Y or X, then you go ahead and say yay. In English, that makes sense. Boolean algebra doesn't work like that. Boolean algebra, if you look at the AND operator or the OR operator, they're binary operators. They have a left and a right, and that's it. Here, if you have the parentheses, you are comparing and saying Y or X. Neither Y or X are Boolean values. However, C++ treats anything that's not a 0 as a true statement. So you're basically saying true or true. That's just going to evaluate to true. So it's just going to be X basically equal to true. That's just what you're basically saying. And now you're comparing a character with a Boolean value. So you're comparing whatever this is, which again is some ASCII value, whatever, 65, I don't know, equal to 1, which is what true usually represents as. Again, that's not true. It's wrong semantically what you're trying to do, and it's also wrong, and it's also not true in the comparison. Okay, so then you get rid of the parentheses. At this point, which one takes higher precedence? I'm going to go ahead and say that this takes higher precedence. Probably because it's just going from left to right. Now, in this case, you're comparing whether x is equal to x. Sorry, to y. So in this case, you're comparing this. So, okay, this evaluates to true or evaluates to false. It doesn't matter because then you're comparing it with a character, which yet again just becomes true. So whether this is 0 or 1 doesn't matter because yet again, this is just going to evaluate to true. So that's wrong. The correct way of doing this is you have to do the comparison. If you're comparing a value with two things, you have to do two separate comparisons and then OR them together. So you have to say x equal to y, or x equal to n, for example. Oh, or sorry, or x, I guess. I also want to compare. I meant to say y or n, but yeah. Okay, and suppose that there's a y or an n or a s. Then you still have to do another one here that says or x is equal to s. And you have to change this. If you're trying to compare this to 5 different things, then you have to have 5 different equals with the ORs then. You cannot just shorthand this. By the similar token, in mathematics, when I try to tell you a number, so here, let me just, I'll leave this commented out. If I tell you a number is between 4 and 8, okay? Inclusive. Between 4 and 8 inclusive, okay? So that means that the number can be 4, 5, 6, or 7, or 8, okay? So I want to check if the number is like that. Normally, when you think of math, you would write it like this. Let me switch to the iPad so I can show you how you write that. So you would say something like 4 is less than or equal to x, which is less than or equal to 8. Okay, that's what you would normally do in math. And we do know that this symbol, less than or equal, is represented as this in C++. So you may be misled to believe that this is an okay thing to do in C++. Like that. But yet again, this is wrong. You can't do this because this expects a binary operator and this also expects a binary operator. So that's not going to work. You have to separate this into two completely statements and then use your logical and and or. So you can say 4 is less than or equal to x, and you can also say x is less than or equal to 8. And in this case, you need to put an and because you want it to both of these statements to hold true. You want x to basically be bigger than 4 or equal to 4, and you want it to be less than or equal to 8. So that would be the correct way of doing that. Not that way. A language like Python does allow shorthand like that, which I don't think it's a good idea because it just teaches bad practices to people. But in C++, that's not the case. So you got to make sure that you understand that the Boolean logic behind why this is the case, okay? Because that's something that, again, when you're saying something in English, you can say, yeah, 4 is less than or equal to 8, or less than or equal to 8, or you simply say it's between them. You see these, you use all these words, but when you're actually converting it into the Boolean logic, you have to be very careful, okay? And the easiest example is, yet again, the first one that we did there, because we say, yeah, x contains a y or an n or an s. So you may be misled to say that that can just be written as one big statement, but no, they're individual ones. X contains y, or x contains n, or x contains s. Not x contains a y or an n or an s, okay? So be careful about that normal speech to actual programming or Boolean algebra conversion. So that was the one thing that I didn't want to forget to say. So now I have not. Okay, so going to switch statements, like I said last time, it's another way of writing if-else statement. The big advantage being that it's a lot cleaner. When you're writing something like this, it's just terrifying to see an if statement with this many else ifs in it, and at the end an else. And if you're trying to compare this with multiple possible answers, like it is here because we're converting an ASCII to an integer, then if this was like a real, if I was trying to convert this to all numbers from 0 to 9, then that would be 10 possible little lines here that I have. I have if c is equal to me, I want to start at 0, and then I go all the way to 9, and then I have a sort of a fall through of like, it's not a real number. This is bad. It's again, poor etiquette of writing code. There are better ways of doing that, and that is your switch statement. So this is this equivalent code in switch statement format. With the switch statement, what it does is you write the keyword switch, reserved word, and then you're going to put the variable that you're going to compare things to. So that's going to be your C, which is what you're comparing over here. And so now you have your different cases, so the different possibilities that it can be equal to. So when I say case 1, it's the same thing as saying C equal to 1. I'm saying, in this case, if C is equal to whatever the case contains, then I'm going to go ahead and run that. Or perhaps I'm looking at case 4. If C is equal to this case. And I said 4 because I'm saying what this case contains. That has to be a literal. That cannot be a variable in C++. In some other languages, you can do that. But in C++, it has to be a literal. So if you have to compare this with an actual variable, then you may be forced to do it in this method. But if it's something that you can compare it with a literal, then you can go with this method. Okay? So next, after you put in the value that you're comparing it to, you got to put a normal colon. And then you start writing the code that's supposed to run. So whatever you would put normally inside of the in the block of the if statement. So in this case, of course, I'm putting the n equals 1 because that's what's happening. And then here's the thing with the case. If you don't have the word break there, so if you have something just like this, what happens is when you go into a case, you run the code there, and then you just keep going. So then you start running this as well. And you would keep going until you see a break. Because the way that people decided to code switch statements is, when you hit a case, you just run the code from the case there and any case beneath it. So by practice, you typically want to put a break right after each case. That way you don't run the cases beneath it. And this is perfectly fine. This is the one situation where breaks are acceptable in like normal programming. Finally, we have sort of the else clause. So there's a fall through, this one at the bottom where like if no case fits. And in that one, we basically call default. And that's a reserved word. You put a colon. You can see there's no case there because again, it's just a default. You can do code there if you want. You can also not do any code. And then you can put a break. So make sure you put that break. Otherwise, weird things can happen. So yeah. Now, it doesn't mean you always have to have a break. There may be situations where, suppose that you want two cases. So like imagine you have, suppose that you were checking for something where you're comparing it to two values. Like maybe if the user has a 1 or a 0, you want to have a 1 regardless, okay? So if that is the situation, then you could put your case 0 and your case 1 together and have them both do the same thing. So you could literally do something like this. And this will have case 1 and case 2 run the same code. So this is also a convenient way of saving lines of code of you writing. Because if you find yourself that a lot of if you write an if-else-if statement and you find that inside of each of these, there's a lot of code that's repetitive, like the same code is being ran. In fact, the exact same code is being ran. Then you could have just put an or here and put the other one. And frankly, that would be one solution. Or you can connect the cases together by putting them separately, but then removing the word break between them. So that's one usage of a switch statement. That's pretty cool. When have I used switch statements like that? In 302 last semester, we were coding a game. We were coding CSGO, and in my solution, one of the things that you had to do was actually press keys in the keyboard to move your players. And you got WASD. You also got the arrow keys if you want to use those. Well, what if they had cap locks on, or if they didn't? Caps locks is like making your letters uppercase. I wanted the game to work with both caps locks on or off, like all games do. If your caps lock is on accidentally, your game's not just gonna break down and no key's not gonna work, right? You need to be able to basically accept uppercase and lowercase. Now, one way I could have done this is I could have just lowercased everything, but I decided to do it a different way, which was with my switch statement, whether the case I had a case for the uppercase letter, for the lowercase letter, and also for example, for W, which is for forward, I also had the up arrow key there. So I had three things in the same case that were going to indicate that the player is moving up. And so I had three cases, and then I had code for that case, for basically moving up. Or for moving down, I had uppercase S, lowercase s, and then the bottom arrow key. So you can see that cases can come in useful when you're basically not trying to avoid writing code twice. Because here's the thing, you don't, I mean, this will come more when we talk about functions, but you don't want to just copy paste code, because copying and pasting code if you're reusing code is a bad practice, because if you want to update the code, now you got to update like 5 different spots in the code to just update something, like to fix something. So you want that to be contained, and that's the whole idea behind something like a function. But furthermore, it adds just more work. And so if you have something like a switch statement where you have 3 cases that are doing the same code, you're only running code once, and you're only maintaining one of that code. You don't have to maintain multiple ones. So it's very useful in that regard. I'm closing the poll. Okay, so that pretty much concludes switch statements and nested looping. Now we're going to talk about that other loop that I mentioned in the beginning of class, and that is going to be the for loop. I have a bunch of code here now. Where did that code come from? I guess we wrote it all. Okay, that's okay. We'll just make another file. We'll call this one the real for. Include items. Into argc. I'm going to start putting this now because you know what it means now. Okay, and then let's make sure that yep, okay, so that's ready to go. All right, however, I'm gonna go ahead and switch over to the iPad to show you the syntax for the for loop. So let me go ahead and pull up the notes here. Here we go. Okay. All right, so we've talked about the while loop. We also talked about the do while loop. And now we're going to talk about the for loop. Okay, and also known as the for statement. And so the for loop is a type of loop that you want to use for count control stuff. So technically the while loop is better for event-based stuff because you check that logical expression. We have been using, for half of the examples at least that I've been showing you, we have been basically using a counter of some sort to run the loop a certain amount of times. The big one that we didn't do that, and that's why I did it, was the one we were reading the text. That's the real while loop usage of that. But because it's very, very popular to kind of count iterations and loop something X amount of times depending on something else, the for loop is very popular to the point that at least in my personal programming, I find myself using the for loop the majority of the time over the while loop. But as I said, pretty sure I said last time, any code that you write with a for loop, you can actually rewrite with a while loop. And actually, you can also write any code with a while loop. You can rewrite with a do while loop. But there is a catch for that one. For that one, you need to have a break statement for the do while loop, and you have to have it right at the top of the program. So like. This is a question that I actually asked, I remember, in the final or the midterm, last time I taught 302, or sorry, 302, or 135. So this is the one case where whereas with the for loop and the while loop, you can rewrite it very easily. with a do while loop, you can convert that to a for loop or a while loop, or vice versa. The one catch that you have to do for converting something from a while loop to a do while loop is, again, the do while loop runs once before checking the condition. So if you want to kind of mimic that same idea, is you can just wrap this whole thing in an if statement that has the same logical expression as here. And then you're done, basically. Or if you want to make this easier on you, then you can also just make an if statement with the same condition and then just say break. That. Except that one you can put a little exclamation point because it's the opposite. So yeah, you can. I'll leave that to yourself to figure out and practice, because I might ask it again in the test. I don't know. So okay. All right. So the for loop. Let me go ahead and write the syntax of the for loop. You have the word for, which is a reserved word in C++, surprise, surprise. Then you have what's known as the initialization statement. You got a semicolon. Then you have what's known as the loop expression, or logical expression, as I've been calling it. And then it's all in one line, but I kind of ran out of space, so I'm going to shrink it a little bit. You have the update expression. Okay. And then, of course, you still got your statements in there. So the code that you're running in the loop. But yeah, this is the basic syntax of your for loop, at least the C style for loop. There is a C++ for loop that's called a range for loop. I don't think we're going to cover that in this class. Or if we do, it's going to be one of those like bonus topics. Otherwise, you'll cover it in 202. Although we have vectors in the assignment. Yeah. So yeah, I'll try to throw it in. I'll try to throw a range for loop in. It's not that hard to learn, but you have to know arrays and vectors for that to actually make sense. So that's why we're not mentioning it in now. But it's kind of very similar to a normal for loop. Okay, so don't get scared with all these fancy names. This one in the middle is the logical expression that you would normally have in a while loop. So that's the statement that whether values are true or false. And so I think the best way to show you the for loop now is, let me go ahead and write a while loop that does something with a count, and then we can convert that code into a for loop. Okay, so let's go ahead and write a program that prints out the letter high, or the word high, 5 times. Okay, so let's do the getaway first. While true, see out high. And I said getaway because we're going to use break and bad practices and things like that. We need a counter. I'm going to call it counter I, just because, I don't know, maybe a reason that'll come relevant later. And actually we'll start it at 0. And then, basically every time that I run this, at the end of it, I'm going to do I++, which is going to increase my counter. And then I need some way to stop it. So I'm going to go ahead and say if I is greater than 5, or actually we'll say if I is, we're coding it the bad way. So if I is greater than 5, break. Right? Because we want it to run, but then we want it to stop when I becomes bigger than 5, right? I think actually this is going to print out 6 times, but we'll see. Yep, it printed out 6 times. Because counting starts from 0. So we got 0, 1, 2, 3, 4, 5, because 5 is not greater than 5. So it's not going to run that. Only when you get to 6 is 6 greater than 5, and then you get this. So then you're like, raw, grumble, grumble, switch it to 4, even though you're trying to print 5 times. Now it runs 5 times, and you're like, yay, I'm done submitting my assignment, right? Your boss looks at this, and he's like, yeah, you get out of here by next week. You're fired or something. This horrible code. Okay, let's unscrew up this code, okay? First of all, we don't want to use break, because we talked about that's a really, really bad practice. So, well, if we still want to kind of do this sort of weird method of using an if statement while keeping an infinite loop, which is absolutely ridiculous, but we're going to keep going for it, because we don't know any better. So we go ahead and we flip it around. Actually, you know, here, let's do it. Like I said, we're going from bad to good. So let's do that. So, okay, your boss, the first thing your boss tells you is don't use a break statement, rewrite this. Okay, so you know that when you go ahead and you patch this, and like this, it was working, you know, with the break statement. But then your boss tells you to get rid of break. So the quickest way that you can do that without having to really think of how to make this better is, well, you know that if this isn't valid to true, then the code's got to run. So then you could say something like else you run this like this. And then you're like, okay, maybe this will work, right? But you're like, this true here has to be something else. So why don't we bring this up in here? You can say, if I is greater than 4, this would work, but it won't because you're counting upwards. So then you flip it around and you say, well, I is less than 4, okay? And you know that it's bigger than that. You would normally write your break here, but you're gonna get rid of that. You just kind of leave it like that, okay? So let's try to see and run that and see what happens. You're getting 4 now. Well, that's because now we flipped this. So you can either do less than or equal to, or you can do the original correct version of 5. So you do that, but you see that it works, right? And now you're like, well, do I really need the if statement like that? It's empty. And this is another thing that I see very popular in people when programming. They write an if statement, and they have an if-else statement, and the if part is just blank, and then the else is here. Because they don't know that all they really got to do is this is a situation. Doesn't really apply for this, but if you really wanted to do something like this, all you got to do is wrap this whole statement in parentheses. Come on, give me another parenthesis. There we go. And then put a not. And now you flip the if and the else part of it. So you don't need to do this weird stuff. So if you do that, then you'd be okay, at least for that. Although here in this case, even though this works, we're really not trying to do this because we don't really need any of this. We already took care of that by putting it in the while loop. So we can simplify the code into doing something like this. And there you go. So you've kind of improved your code from some weird break horrifying thing to at least something more decent, okay? So I'd say this is okay. This is good code now. It says while I is less than 5, C out, I++. Good, good, good. Okay. Now I'm going to show you how you could do this with a for loop, okay? The same exact code. First, I'm going to go ahead and take the line that's supposed to run, and I'm going to copy and paste it down here, okay? Next, I'm going to write the little definition to for loop, which has to write for, parentheses, then init statement, then a semicolon, then loop expression, semicolon, then update expression, and then my curly bracket, and then the other curly bracket, and that's it, okay? So now I got to replace these things with the right things, okay? The right values. The loop expression is when you want the looping to stop. That's going to be this guy. So you're going to copy it from there and paste it here. Well, I is less than 5. The initialization statement, the way this works in the for loop is, when you run a for loop, it sees the word for, and then it runs this piece of code one time, and only one time. And it's sort of the initialization. As a word, it kind of indicates it initializes things that you need to initialize. From there, when your code runs, the next thing it's going to do is it's going to check the loop expression. If it evaluates to true, then it's going to run the body of the loop. When it finishes the body of the loop, instead of going immediately to the loop expression, because it's not going to run this again, because again, I said it only runs once, it's going to go to the update expression, and it's going to run any code that you have here. So when this finishes, it goes here, runs this piece of code, and then it goes ahead and looks at the loop expression. If it evaluates to false, then you're done, it gets out. If it evaluates to true, then you go in the loop again. Run the loop. At the end of the loop, then you're going to go and you're going to run the update expression again. So it's going to update whatever it needs to update. Then it's going to run this again. If it's true, go in again, end of the loop, run the update, check this again. Run it again, blah, 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 update. Maybe now this is false, it gets out. Again, when you see the loop for the first time, it runs this one time, then it checks this. If it's true, it goes in, runs, then it runs this, then it goes here and checks this. If it's true, it runs, then it runs this, checks this, maybe now it's finally false, it gets out. Other scenario, you go in, run the initialization, you run this, it's false, it just gets out. Neither this was run or that was run, okay? So in our case, what could be the initialization stage? Well, in the for loop, this is where you initialize the counter that you're gonna use to count the number of times you want the loop to run. In this case, that would be the I, because the I is the one that we're basically using to decide how many times it runs. And we want to set it to 0 so that we increase it one time every loop until it gets to 5. Okay, where can we do the increase part? We could do it down here, as we had it before. And this would be okay. However, we could also do it here, because this is the thing that runs before. So we can actually do the counter increase there and not have to do it down here. And bam. Now you have a for loop. And as you can see, all this code versus this code, this is far more elegant and clean. And they can get even cleaner. The initialization here, I don't have to just update variables. I can actually declare them. So I can say int I equal to 0. And now, I don't even need this I. So I could comment out this entire piece of code. And here I'm declaring my I. I'm using it by saying hi and then increasing it, comparing it, and when they get out, it's gone forever. And I don't need to worry about cleanup or reinitializing or things like that. So it's a very elegant way of doing count-based looping. And if I go ahead and run this piece of code, you can see that it prints out hi 5 times. Rewind the video if you're watching on YouTube. If not, then just rewind it in your head of how nasty we started doing something. Then we went to at least a clean way of doing a while loop, but now look how quickly and cleanly we did this with a for loop. One line of code, basically. Pretty good, huh? So that's, again, remember, code is art. You're making your masterpiece. You want to make it look good and clean and short. People look, when the people see short code, they're like, wow, this guy's really smart. He was able to do this really complicated task in like 3 lines of code. People like that. They respect that. They admire that. So you want to strive to do that kind of stuff. You know, you want to say a lot in as few words as possible. Even in speech, that's a pretty valuable thing, right? You want to be able to express your ideas in the least amount of words, which, you know, people are like, he's very eloquent. He knows how to express himself in a short and concise way. So, yeah. Okay, let's go ahead and go and do another for loop here. Actually, now let's do some math. Let's do a nested loop again, like we had initially. So let's go ahead and do another I equals 0. Because of scoping rules, I can redeclare this, and it's not touching this one because it doesn't even exist anymore. So we're okay there. And even if this one existed, that'd be okay. Like, this is okay to exist. It's just using another one. Like, it's just because it's its own scope. This is within its own scope, so it doesn't mess with this one. So that's perfectly fine. Now, I guess this would be a good time to talk about why I chose I. I don't know why, I don't know how, I don't know when, but at some point in time, somebody decided that when you're using a for loop, the very popular variable to use for your counting or your iteration is an I, just an I, like this. Maybe because I stands for iterate, you know, or iterator. That could be probably why, but somebody decided that. So it's almost like, even though there's no rule anywhere that says you must use an I there, you just do it by nature. And furthermore, when you do nested loops, the second nested loop usually uses a J, and the third one uses a K. And that's just, again, practice. Like XYZ, you know, IJK. I don't know. I'm just telling you because it's a thing. So you might as well know it. So like, let me do a nested loop here. So I'm going to use J here. Now, what happens if I use I here? Okay. That's kind of nasty because this could be okay, but it can also go wrong real fast. Let me comment code out so you can see better. Read something. Let's check messages. We got a couple of exclamation points. How many did we get? Well, we should have gotten about 25 of them, but so we can see that, maybe let's decrease this to 6. Here we go. We got 6. So notice here that I'm using the same variable I, okay? There's no problem because this I only exists here and this I only exists there. Right. Here's the thing. More than likely, if this is a nested loop, it's because you want to access this at the same time you want to access this. When we get to arrays and two-dimensional arrays, or in general using anything that's more than one dimension where we need to keep track of two things, you will see that this is one of the dimensions and this is another dimension. If this is a number of words, then this is a number of letters in a word. And because of that, you want access to this variable. So that's why you want to use a different letter here. Like that. And so now you can access both. So maybe you want to do something like cout. Let's do I, and then a space, and then a J. You know, I never use car, so let me go ahead and throw a car by making this into a car. A car space. Now you can see all the pattern here. 0, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, right? So if we were trying to access like indexes of a column in Excel, think about that, then now we can basically traverse every single column of every single row, every single cell basically. So this is an example of a nested for loop, and I can go deeper. I can do another one. So int k equal to 0. K is less than, let's say that third dimension only has 2. K plus plus. And now let me go ahead and move this in here. I mean, I don't have to, but it's just to show you. And so IJ and then let me K. So as you can see here, we got 0, 0, 0, 1, 1, 0. So hey, then we did like a little binary counter. Oh, no, never mind. We got the 2 there. Not true. But here. But it's going, as you can see, sort of by counts. We did this would be considered a ternary counter, I suppose. Yeah, this is kind of like a ternary counter. You know, instead of binary, ternary, like 0, 1, and 2. You know, like quantum, you'd have qubits and stuff. So, yeah, that's basically a for loop for you. You initialize it, you check here typically when you want the counter to end, and then you increase it at the end of each iteration. People used to say that if you use ++i instead of i++, it's supposed to be faster. Like C people said that, and maybe that was the case back in the day. Now it doesn't matter. The compiler is smarter. It knows what to do to make it more efficient. You don't necessarily have to have a single statement here. You could write an entire program here. Like I could say cout increase, maybe line feed, and then I could put in here I equals 2. Increase that by 2. And I think that should work. It doesn't like the fact that it's 2. So maybe if I put it in curly brackets, I can get away with it. Didn't let me. Expected primary expression before the curly bracket. How can I get away with putting other things in here? I might not be able to as easily. There's ways you can do that. Obviously now I'm trying to do things that I really shouldn't be in the first place. So maybe we shouldn't even try to do it. But what you can definitely do is I forgot to get rid of the other ones. You can change it by more than just by 1. So in this case now I'm going by 2s. It's a little bit harder to see because I don't have that much of a counter going. But let's make this a bigger number, like let's make it 8. You can see that the outer variable, the 0, is going to 2, and then to 4, then to 6. And then we don't see 8 because when it hits 8, it gets out immediately. But if we want to see 8, we can do less than or equal to. Then we will see about 4 8s. Yeah. So in this case, I am doing my update expression to be not just a single plus 1. I mean, that's the most popular one when you're counting. You want to count by 1s. But you can, nothing stops you from counting by 2s. Or you can make this a multiplication. You can even count down. Let's do a count down. So let's set this to 10. And then we're going to say I is greater than 0. So we're going to stop when we get to basically a negative, or 0 actually. And then here, of course, we don't want to make this positive because then this will loop forever. But we can make this be basically I is equal to I minus 1. Or I could do I minus minus 2. And as you can see here now, we're counting down. We start at 10. We get to 9, 8, 7, 6, 5, 4, 3. Where's 3? Yeah, 3, 2, 1. Or I could count down maybe by 3s. And you can see there goes 10, 7, 4, 1, and nothing. I could also do division. Let's see by halves, you know, like so it's gonna be 10, 5, and then it's gonna be integer division. So actually it's gonna go 10, 5, and then it's gonna go to 2, because the way that works is 10 divided by 2 is 5, but 5 divided by 2 is 2.5, but it drops the decimal, so it goes to 2. Then 2 divided by 2 is just 1, and then 1 divided by 2 is going to be 0 because it's 0.5. So yeah. So you can do that. You can also, even though this is a for loop, you don't have. I mean, this could be anything here. So like, I could go back, and maybe we'll do that as a final example. I can go back to that one file processing thing. I mean, I kind of really like this one. G++ as loops one, I think. Let's open it up and let's find out. Yeah. So I can go back here and I can replace this guy or this guy with a for loop. This is an event based though. I mean, it makes sense to make it a while loop, but just to show you that you can replace this with a for loop. What I'm going to do is I'm going to comment it out and I'm going to say for. What is my integer? I'm just going to leave it empty for now. Oh, by the way, if you ever want to do an infinite for loop, which I don't know why you would, but if you want to do that, of course, with a while loop, you can just say while 1 or while true. With a for loop, all you got to do is put for, parentheses, and the 2 semicolons. Basically, I'm leaving blank the initialization, the comparison, and the update. That's just going to run forever. That is right there is an authentic infinite for loop. Don't do it, of course. If you did, you'd have to have a break statement. So that's already a bad sign. But it's good to know. It's kind of cool. Anyways, in this case, we're going to leave empty the initializations part. We're just going to put in the middle part, the logical expression, we're going to put our cin temp. And we're also going to leave empty the output part because we don't need to do anything to that. Yeah, so yeah, that's going to be pretty much our for loop. It's kind of empty. Oh, curly bracket. Don't forget. By the way, this does bring up a good point. One single curly bracket gave me like a dozen errors. Don't panic. The way you want to figure this out is go to the top of the errors and look at the first error. It says cout does not name a type. And you're like, what? This line looks perfectly fine to me. And it is. But go to this line. Go to line 30 and find out. You go to line 30 and then you're like, this looks fine. But here's the thing. Before there's a curly bracket, that is a sign that your curly brackets are unaligned. And they were, because before this was here, I was basically, this curly bracket here was closing my main function instead of closing the for loop. So if you get a bunch of errors, don't panic. More than likely, it's due to, I mean, there may be multiple errors in your program, but still, go to the first thing, and that should give you a hint about what's happening. And as you can see, the moment I fix one single line of code by putting the curly bracket back, now all of a sudden no errors. So that's because basically when the parser is looking at the code, it just assumes that your code is right. So it assumes the curly brackets are off. It just thinks that that's the way you did it. And so it's trying to force its way to the rest of the code, which just generates a waterfall of errors. And you fix that initial part, and it, it's like you close the leak and the flow stops. So anyways, I run this again. Forgot to give it the input file. And as you can see, it still works. Like we got the 4562, and then I think this was the number of Z's in it or whatever we had. But yeah, here you have a for loop. So anything that you can do with a while loop, you can do with a for loop. Of course, this is the wrong tool for the wrong job, really. This is much better for this scenario here, but just for the sake of showing you that it's possible, I decided to do that. Let's see. I think that pretty much covers the for loop. It's very, very popular. It's very, very useful. As we talk about more stuff, then you will see more practice of it. But I think at this point, it's a matter of just understanding the syntax of it. This is the part that runs when your loop starts to initialize things. This is the part that runs every time it wants to check whether it keeps going or not. And this is the part that runs at the end of each iteration, so it updates. So usually this is where you update your counter that you're using to count the number of times that you run this. Let's see. Yeah, that's it. That's going to complete chapter 6, which is repetition and iterations. Statements that allow an action to be repeated. Now you know your do while, you know your for loop, or for statement, and your while statement. Anyone have any questions? Anything? You guys are very quiet. Like I said, the for loop, nested for loops are very useful for when you're dealing with like rows and columns. Like if you're trying to process an Excel spreadsheet, you gotta go. You can say that all of the rows, that's the outer loop. You go row 1, or actually no, it makes more sense to go each column. So no, row. Yeah. Each row, you can think of each row as your outer loop. And then within each row, you want to look at each individual cell, which is in each little column. So that could be your second loop, right? But now if you go into a higher dimension, into a 3D world, each spot, can have a depth to it. So that can have little columns within it. So like I said, it's hard to go over that without going over arrays. So really you'll get to see the power of loops when you learn about arrays, which you will after the midterm. So all right, you guys buy it. Cool. So okay, so the for loops would be good for doing math with arrays, since that's like Excel? Yes, pretty much, yeah. So anytime that you're dealing with tables, which are arrays essentially, for loops are amazing because you use the size of the tables, like the number of rows, number of columns, whatever it is, use that size, as we did actually earlier, and then you basically make that be your counter. When you get to that size, so I is less than size, you stop. And it's a very, very popular thing to do. In fact, I guess that there is one other little update that I can do to the program. That inner loop is a much better example of something to do. Yeah, this one right here. So, well, this one we definitely want to leave as a while loop. This one is a much better situation where a for loop would probably be nice. Yeah, this one just screams for loop to me because I got a little integer here and I'm initializing it. So yeah, let's put that one as a for loop. We'll call that index. We'll call it the same way, even though I. Oh, by the way, maybe I stands for index instead of iterator. I don't know. Like I said, who knows? Big mystery. Doesn't really matter. That's why I've never really looked it up. Index is less than temp size, and then my increase is index plus plus. Yeah, this one was born to be a for loop. And then we can just copy and paste the body of the loop, and bam. We've just took this code, which was 1, 2, 3, 4, 5, 6, 7 lines, and turned it into 1, 2, 3, 4, 5 lines. And actually, we could, you know, yeah, well, whatever. We're counting that line in both situations. So yeah, we've decreased the size of the code. I wouldn't say considerably, but you know, we save space. And we also, I think, made it more readable. Because when I see for loop, just like you're saying, I think of like tables, columns, counting stuff. It's just very built into your brain. You see a for loop and you know stuff is counting. You can very easily see what the stop of the count is, how quickly you're counting, and from where you're counting from. And you don't have to start by 0, by the way. This whole starting from 0 thing is a very computer sciencey thing, but it's perfectly fine to start from 1. You just have to kind of take that into consideration when you're counting stuff. It's just like with arrays start from 0 in C++, so that's why we typically count from 0. But yeah, this would be the equivalent. Let's just make sure I didn't make a mistake. So let's just try to run it one more time. Yeah, it's all good. Let's try another letter, by the way. I don't know. Let's do Y. I'm curious. This is random curiosity of what is the number of Y's in there. 337. Wow, that's a big difference from Z. So, oh, you know which one would probably be popular is C, because it's a C++ article, so maybe there's a lot of C's in there. Yeah, 894. I don't know. Actually, I don't even know if that made a difference, but yeah, okay. So, all right. I had a question about the program. Do you know if there's a way in Visual Code to monitor the current variables like in MATLAB? Yes, that is called debugging, and you have to set it up. The way you set that up, and actually, I wonder, maybe I can set it up on the go. And you know, that's probably a better thing to do, because then we can do file input output next time. So let's give that a try. I just set it up on my other machine, because I set up a VMware machine. I regret not recording setting that up. But I don't think I have it set it up here, so let's try to set it up. So the first thing you gotta do for that, and there's no guarantee that it's gonna work, so we'll see, is you have to create a project folder. So we're gonna call it a debug test. Okay, and let me make sure you can see that by moving this out of the way. Okay, so I got a little folder called debug test. And then go ahead and right click on it and then say open with Visual Code. And now you should see here debug test, which is the name of the folder. Create a new file in there and let's call that test.cpp. And here, let's just do a hello world program. By the way, I don't think I ever said this, but you might be wondering why I keep, or at least why at some point I said like, I'm going to write a program called Hello World. It turns out that this is just a sort of a tradition that the first program you do in a programming language that you're learning is a program that has the word Hello World in it. I'm not sure more about the history of that, but yeah, that's pretty much why. So, okay. From here, make sure, I guess, before we go any further, go to extensions, and then make sure, look up in extensions for C++. And make sure you have this installed. It's the first one is called C++ IntelliSense Debugging and Code Browsing. Make sure it's installed. If it's not installed, it'll say something like install. In my case, it's already installed, okay? You need that to be able to do the variable watch and debugging. So once you have that installed, what you need to do, and hopefully I remember this, is you need to go to File, Preferences, Settings, and then go over here and click the little Open Settings JSON. And then I think here you have to do, what is the settings you have to do here? Trying to remember, I did this yesterday. I can't remember off the top of my head. Let's just try to hit start debugging and see what happens. Ah, here we go. Select environment. Click this. G++ build and debug file. Sure. Okay. Yay, that worked. Okay. So what you do is you got to go up here in the settings, and you can't see the settings right now, but I can try and make you see them. So if you go up here, you go to file, you select your file, go to debug, hit start debugging, and then you're going to see that little menu that came up, and then you select there G++, and then it should automatically pre-fill this launch JSON. If it didn't, do what I was doing earlier when I said to click that thing over here when you go to file settings, and then just literally put this in there. The only thing you got to make sure here that is okay is this address here. That address has to be the right location. Again, this is for Linux. If you're doing Windows, then this changes a little bit. You have to go on YouTube and watch that. But yeah, once this is good to go, then you can debug. At this point, let's try. I mean, int A gets 5, A gets 4, cout A. Now, I believe if this is set up correctly, you can click on the left here and set up what are called the breakpoints, which means it'll stop the execution of the program. And then you can click start debugging again on the menu. Cannot find task debugging. Ah, dang. Debug anyways. Let's see what happens. It's not letting me. Well, normally it would let you like this. In fact, I can show you that by opening my VMware one. That's why I set up a new one, because I like it better. Let me go ahead and open that one up, and I'll show you that. So let me actually switch over to this one. Oh wow, you can see that even though it's minimized. Interesting. Let me show you what it should look like when it's working. This is VMware. This is the alternative to VirtualBox. That's much better. So let me go ahead and launch this. Hopefully it doesn't lag, because I did set this to use a lot of the memory. So we'll just wait and hope. But VMware is available to you for free. You have to request access to it through the Tux website, which gives you like a key that you can put into the program to download and use it. It is better than just compiling the terminal and seeing any errors probably there. The compiling is not the part that this is going to help you with. You still want to compile in the terminal. What's going to help you is if your program isn't doing the right thing, what you can do is you can actually monitor the program as it runs each line of code. And you can look into the variables like that you have and see if the values there are right. And for example, in the loop, you can see it going in circles. And by seeing the code line by line, you can sort of compare it to something by hand and see if it deviates somewhere. And it's a really good way of figuring out errors in your program. It's not very popular at this point in time because you're still learning the program. But like, you definitely want to learn this before you start taking Tool 2. And sometimes it's not covered in class, but you know, it's just something you pick up on your own. I use GDB Debugger, which is terminal based, but that's even more complicated. I don't want to show you that because I have a video on that if you want to see it on Canvas. Oh yeah, I mean, you should. This is so much easier. Like, okay, if your code doesn't do something right, you don't want to just stare at your code for 2 hours and hope that like illumination shows you the problem. You just want to be able to basically see the error like happening and know where it is so you can fix it, right? Okay, so here we got another Linux. This is a 1.2.20, and I created a test file. I created a test project. So open without application, Visual Code. This might be a little small in font, but don't worry. And again, hello world. Let's try to run it over here and see if it runs before I do anything. Or, I mean, I promise you it was working last time I run it yesterday. Yay, it ran. Okay, so in this case, I went ahead and hit run, start debugging. And I put these little red dots here. Those are breakpoints. Those are like little flags to stop your program running at that point. Now here, I'm gonna switch over to the other setting here. Don't worry. Like that. And then I'm gonna zoom in a little bit so you can see it better. All right, we'll go with that. It's not too big, but then again, it's not as important to read what's happening. Maybe just a little more. Also, I think I might have screwed up the aspect ratio, but that's okay. All right. So when I'm running it, I have this thing called variables, locals, and I see A, B, ARGC, and ARGB. Because I have an A, I have a B, and then I have the ARGC and ARGB. Remember that from command line arguments? ARGC is 1 because I just ran it at ./a.out. ARGB is some weird value because that's actually the address in memory where it's kept, and I can actually look into that, and it's a little table. Remember, I can look at the contents of the table by scrolling down, and I can see here that the first value is a slash because it has the name /a.out. That's the executable name. Now this is a little bit glitched out because it's just showing me the slash instead of showing me the /a.out. But you know, it's just the way that is there. But the important thing is you can see these variables here. The compiler was nice enough to initialize them to 0 in the debugging mode. You can't trust that. But now I got a bunch of little icons here. What they do is they allow me to go through my program line by line. The most important one is the step over. Step over is just going to go to the next line of code and then run that code. There's also step into right here. Step into basically enters into a function if there was one. We're not using functions, and we haven't really talked much about functions yet, but like we have used like CMath, POW and stuff, right? If I actually want to see what the code looks like for POW, doing this step into would actually show me that code. We can try it actually in a second, and if things are set up correctly, maybe it will show it to us. So let's do A gets POW A comma B. And then I guess I gotta include the CMath library for that. But yeah, if you do what I showed you before, you should be able to do this. It's just that in my specific Ubuntu, that's an old one. It's kind of glitchy. That's why I made a new one, but it was working fine in the new one. So you shouldn't have problems if you follow, even though I had errors. If you follow what I did, you shouldn't have an issue. But anyways, okay, we're back to this now. I run a line of code. Notice that A has a 4, but B has a 0. If I do the step over, now B has a 3 in there. So I can keep track of what's in the variables as I run this code. And that's very useful because like if there's a bug, if there's something wrong with your program, you can go line by line and see at what point things deviate from track. And now, you know, once we start later on in the class and we talk about arrays and functions, maybe we can run this debugger so we can see the execution and actually kind of play more with it because we haven't learned enough. But let's see if the step into will actually get us into POW. I did not. Nope, it just skipped over it. Sometimes it would actually show me the code that POW is built into, but in this case it did not. It's okay. But anyways, you can see here that A has an 8 in it because... Should it have an 8? I don't think that's right. Think about that for a second. A had an 8 before, and we're doing 8B, so it should have like a 20 something in it, right? That's weird. Let's go ahead and stop it and run it again. Oh, maybe I know what it is. I never built it, so I have to build it again because it's kind of weird. You have to manually build it, and you have to do -G. But okay, let's try it again. Okay, so let's try this again. So we're gonna go and step into. There we go. It worked this time. Okay, so now this looks all scary. That's okay. I did step into, so this is actually showing me the code that is how POW is built. Templates and stuff is something you learn in 302. You can see here there's a lot of weird and scary stuff. That's okay. We're going to keep just running back, but that is how POW is actually implemented. That is the code that somebody wrote so you can use POW. And when we come back from that, you would see, now it's kind of complaining, so let me try to step out of all of this. There we go. And step over that. We can see now that this has 512. Yeah, it actually stepped into the library itself. Yes. It showed me that. See, CMath. It says CMath right here. If we go all the way to the top, there's somewhere here in the description that actually says this is a CMath library. And it includes other things. And how big is the CMath library? Look, at least this specific file is almost 2,000 lines of code. And it has all the different functions that you're using. Let's look, for example, for absolute value. That's calling absolute value, but that's not absolute value itself. I think this one's absolute value right here. So, yeah. So it actually stepped in, which is kind of cool, but useless for us, right? But if we had a function that we actually created ourselves, we may want to step in and see it. So, yeah, that's going to be step out. I did say like that. That's how you get out of the function. So, like, once you go too deep into the code and you're like, oh, that's not my code, you can step out using the step out key. The play or continue is going to fast forward in the code until it hits the next breakpoint. In this case, we have no more. So when I do this, it's just going to terminate the program. But if I have one right here, and maybe I put a couple here like that, and then rerun this code with debugging mode, if I hit continue, it just skips all the way to the bottom. Okay, so that one's kind of like the fast forward. Pretty useful because when you're debugging like big code, you only want to look at the part that's interesting to you. So you can sort of put a breakpoint right before the interesting part. Also, if you have a loop, right? If you're in the for loop and you don't want to watch that for loop run like 20 times, you can just put a breakpoint right after the for loop so that it can continue from there. This is restart, so I can bring you back to the beginning of the program, basically stop the program and rerun it. And then this is the stop one to basically stop debugging before the program ends, like once you found your error. So we got 2 minutes left, so let me go ahead and throw a little for loop in here. I is less than 10, I plus plus. Maybe, yeah, let's put the see out hello world in there, like that, okay? Just so you can see, oh no, it's better to put more lines so you can see them. I don't know, this is just random stuff. And then maybe like A gets 3, and then I don't know. A gets 2 plus 1, 3 again. Yeah, okay, let me compile it. When you compile for debugging, put a -G as the argument. Right there, you see that? So yeah, that's what I'm doing down there. Go ahead and run it again. As you can see, this environment is so much nicer than the one I'm using in class. Eventually, I'm probably going to switch over to using this permanently. Like I said, I just set this up yesterday. So yeah, okay. So from there, we're going to go ahead and hit step over. And you're going to see it go into the for loop. Look at the eye right now. Oh, you can't see it. You can barely not see it. Look at the eye. It has some weird value in it. Bad thing, right? But we initialize it. You'll see that gets set to 0 pretty fast. Bam, set to 0. Now A has a 512 in it. Not anymore. Now it has a 3. Now it has a 3 again. hello world would print. Actually, if I look down here, it's hello world there. And then as you can see, the little line went back to the top. And if I do this, it's gonna keep going. You know, where am I at? I is 5, 6, 7. Of course, it's not refreshing. I gotta kind of give it a second. But if I don't want to wait, I can just hit play, and it would go to the next, because I have a breakpoint after the loop. It would go there. And as I was running it, the code was slowly being printed out. So that's also useful. So you're literally watching the program step by step. It's very useful. Try to set it up if you can. If not, then it's okay. Let me know. We can try to help you out. But yeah, that's a little quick debugging thing since we have a little bit of extra time. Tomorrow we will start and finish talking about file input output, which will be the next assignment. Well, actually not the loop assignment, but the one after that. So if you have any questions about the loop assignment, we can talk about them next time. But yeah, cool. All right then. Well then, I'll see you guys tomorrow, and yeah, that's it. See you guys. Bye.